Hello students, this is part 2 to SOL G6, and this time we're really going to look at the value and power of this congruent statement. Here we're going to continue working on algebraic methods to solve and prove triangles congruent, but this time we're going to be given that the triangles are congruent, and we're going to use that information to find valuable information about the triangles. All right, so let me slide this up so we can see better. Our directions here say use the congruent statement to solve. So let's take a look at this congruent statement here. We are being told that triangle PQR here on the left is congruent to triangle WTR on the right. And remember that the order in which the statement is written matters. It tells us what parts are congruent. So I can now, to unpack this congruent statement, I'll know that angle P is congruent to angle W. So if angle P is 40 degrees, that means angle W is also 40 degrees. Also, angle Q is congruent to angle T. All right, we don't know either of those angles, but we can do a little bit of basic problem solving and figure it out. Down here in the second triangle, I've got 2 out of 3 angles given to me. Using the triangle sum theorem, I know that the 3 angles have to add up to 180 degrees, so I can subtract what's given to me, and what's left will be the value of angle T. So 180 minus 85 minus 40 leaves me with 55. So angle T is 55. And since angle T and angle Q are a match, angle Q is also 55. And then finally, we're told that angle R matches itself. Well, look at the picture. Why would angle R be congruent to itself in this picture? We have a set of vertical angles. So, of course, we know vertical angles are congruent. So, angle R matches itself. So, I'm going to color code this picture to match up with that congruent statement because we know that colors are helpful in understanding pictures. So angle P matches up with angle W, angle Q matches up with angle T, angle R matches up with itself. Now we know the measure of all 6 angles. Angle Q, 55 degrees, angle W, 40 degrees, angle T, 55 degrees. Okay, I have another example of finding angle measures using a congruent statement. I'm going to work it pretty much the same way. Here I'm given that angle P is congruent to angle G, P and G. So we know that angle P is 97 degrees, so angle G is also 97 degrees. Next, we know that angle Q matches up with angle H. Angle Q and angle H are a match. Okay, I don't know either of those angles, but looking at the second triangle, I can solve for angle H using the triangle sum theorem. I know that all 3 angles have to add up to 180 degrees, so if I subtract away the 48 and 97, I will know what angle H is. 180 degrees, take away 48 degrees, take away 97 degrees, leaves me with 55 degrees. And finally, our last angle, angle R, matches with angle K. And angle K is 48 degrees, so angle R is 48 degrees. So we've got angle Q at 55 degrees, angle R at 48 degrees, and angle H at 55 degrees. Okay, our next algebraic practice is going to be working on side measures. Take a look at this third example. We are given that triangle WPM is congruent to triangle KPM. And then we're told some information about the side lengths. WM is x plus 3. mk is 2 times x minus 3. So using what we're told here that the two triangles are congruent, angle W matches angle K, angle P is equal to itself, and angle M is also equal to itself, then it's easy to see that side WM and side MK are the congruent pair. So while the sides are congruent, that means the side lengths are equal. So I can set up a simple equation. X plus 3 is equal to 2 times x minus 3. Now my approach to solving for x here is to distribute 2 times x and 2 times negative 3. I have x's on both sides of the equation. So I'll subtract this x and bring it to the right. I have numbers on both sides of the equation, and since I brought the variable to the right, I'll send the numbers to the left, so I'll add 6. And I'll have 9 is equal to x. Now that is not what the question is asking me. The final question says find WK. So I'm going to take this 9 and start plugging it in. 9 plus 3 is 12. And if WM is 12, then that means MK is also 12. And my goal is to find the entire length of WK. So 12 plus 12 is 24. So that took a little bit of everything. We had to match up our parts, we had to set up an equation, we had to use our algebraic skills to solve, we had to plug back in to actually answer the question. I think we're going to be using a lot of those skills in this final example. Here we've got two separate triangles congruent to each other. We're asked to find both x and y, so we're probably going to need 2 places of workspace. First, I'm going to match up my angles. I've got angle M matches angle P. No measure there, so that didn't help. Angle N matches angle R. Okay, so now I have some information that can help me. It looks like I'll be able to solve for y. If angle N and angle R are congruent, then that means 1.5 times y is equal to 41.4. Algebraically, solving for y, I need to divide off this 1.5. I'm going to have to go over here to my calculator. I'm going to pause the video while I use my calculator. Okay, I'm getting 27.6 for the value of y. Okay, I've got one more angle to match up here. Angle O matches with angle T. Now, I think that's just another way for me to solve for y. I don't need to solve for y, so I'm going to leave that alone. But this has also helped me figure out what equation I can set up for x. So I've got on the right side, the only side measure I have is 24, and it's between P and R, my yellow and pink angles. So I have to come over here to find the match. I don't want to use 2x minus 6. I want to use 3x minus 9, which is between M and N, my yellow and pink angles. So my equation to solve for x will be 3x minus 9 is equal to 24. Okay, I need to add the 9 over. Solve for x. 24 plus 9 is 33. Divide by 3. And I'll get x equals 11. Okay, this concludes the end of this video on G6 Part A. This is the second half of that SOL. Hope you enjoyed that. Next, we'll be looking at coordinate methods. Come on back.